हाँ बच्चों, we were discussing the primal problem. I'm again going to write down this primal problem. What was the problem which we were discussing in the last class? This was the problem. Minimum z is equal to x1 plus x2 subject to 2x1 plus x2 greater than equals to 4. Another constraint was x1 plus 7x2 greater than equals to 7, x1 comma x2 greater than equals to 0. Now let us convert this into the dual problem. This we have already discussed couple of times in our last classes. Now again, if your original problem is of minimization time, your all constraints should be of greater than equals to type. For converting into the dual problem, your dual problem will be of maximization type. How many constraints? There are two constraints, so there will be the two dual variable. Let y1, y2 be the corresponding dual variable. Be corresponding dual variables. So maximum W is equal to 4 y1 plus 7 y2. Clear? So subject to compare the x1 2y1 plus y2 less than equals to this is the value in the objective function minimization find 1 into x1, so this is 1. Similarly compare x2, this is y1 plus 7 y2 less than equals to 1, y1 comma y2 greater than equals to 0. Now if you look at this problem, now I'm going to solve this problem actually. Minimum W is equal to 4y1 plus 7y2 subject to. If you look at the constraint, this is the less than equals to type 2y1 plus y2 plus s1. We are going to introduce slack variable s1 because left hand side is less than equals to the right hand side. So we'll have to add the value here. Similarly, y1 plus 7y2 plus s2 is equal to 1. Clear? Again, y1 comma y2 comma s1 comma s2 greater than equals to 0. So here it is 0 times s2. Clear? So calculate IBFS. What is IBF? This is initial basic feasible solution. Whatever the variables are there are two variables y1, y2 put to be equals to 0. From first constraint, you get the value of s1 to be a positive, s1 is equal to 1, s2 is equal to 1. So this is satisfying this one. So we can go with the iteration part. Means, what is the value? We are getting maximum W is equal to what? Substitute the value here, y1 is 0, y2 is 0, 0 times s1, whatever the value is s1, ultimate effect is 0. Clear? So do the iteration CSV, EI. Now this method, this is y1, y2, x1, x2, b. So what happened here, from first constraint we got s1, that is equals to 0 objective function, s2, 0. So the coefficients are 2, 1, 1, 0, 1. So 1, 7, 0, 1, 1. Clear? Any doubt so far? Anybody having any doubt so far? Okay. Look at here now. Here it is Cj. This is 4. I'm doing the iteration here. 7. This is 0. This is 0. If you look at this one, S1, S2, this is the unitary matrix. And what will happen when your unitary matrix will be at y1, y2 place? You will have an optimal solution. Now calculate Ej. When I am calculating Ej, this multiply with this multiply with this. So add it. So this iteration, this procedure has already been explained. So basically this method is known as the simplex method. When all the constraints are of less than equals to type, you are going to apply the simplex method. Choose the maximum This is theta calculate. We know the value. How to calculate the theta? Now, for calculating theta, the b divided by the corresponding column. 1 by 1, 1 by 7. Choose the least value. This has been chosen. This is your key element. Now we do the another iteration. CSV, EI, Y1, Y2, S1, S2, B. What happened here? S1 will remain as it is. So S2 is replaced by Y2 having objective function value 7. So make it 1 because whatever the iteration we are going to do, we are going to do on a key element or a pivot element. So make it 1. So divide whole question by 7. This is 1 by 7. This is 1. This is 0. This is 1 by 7. This is also 1 by 7. So here it is 1. We have rest of the elements in that column will remain 0. So here it is only there is one one element which is there in S1. So here it is 1, here it is 1. So do the iteration 2 minus 1 by 7. This is 13 by 7. If you take the LCM, 1 minus 1, this is 0. This is 1 minus 0 is 1. This is minus 1 by 7. Clear? This is 1 minus this. This is 6 by 7. Is it okay? This is Cj. What is the value of Cj? Here it is 4, 7, 0, 0. Calculate Ej. Again, this is 1, this is 7, this is 0, this is 1. Clear? So multiply whole question in when corresponding elements, if we multiply with add it, ignore this one because here it is 0. So look at here, this is the value which we are getting. So Cj minus Ej. Here it is 3, here it is 0, here it is 0, here it is minus 1. Anybody having any doubt so far? Anybody having any doubt so far? So here it is 1. This has to be Cj minus Ej. Now this is the value which will be chosen. When we work on here, this is theta here. This divided by 6 by 13. Clear? This is 1 here. So choose the least one. This has been chosen. Clear? So do the iteration again. See, most probably will get the here the optimum value. Because why? The reason being now S1 is going outside and Y1 is coming inside. Y1 having objective function value 4, Y2 value 7. Clear? This is 1, 0, 7 by 13, multiply by 7 by 13. When I multiply by 7 by 13, this is S2, this is minus 1 by 13, this is 6 by 13. Anybody having any doubt so far? So 1, 0, 7 by 13 minus 1 by 13, 6 by 13. Here it is 1 by 7, here it is 1. So divide whole question by 7. This is 0 here. This is 1 here. I divide by 7. This is minus 1 by 13. Clear? And here it is 1 by 7. Clear? Plus 7 by 1 by 91. So 91 is LCM. 13 1. 14 over 19 1. This is 2. This is 13. This is 2 by 13. So here it is Cj. Here it is Cj. This is 4, 7, 0, 0. Anybody having any doubt so far? So what is the value of here? We are left with this one also. 1 by 7 minus 6 by 91. Clear? 91 LCM. This is 13 minus. This is 7 by 13. This is 7 by 13. Look at here. Again, I am going to let us check it. Maybe there is minor mistake. Look at here. What is value here? Here it is 1 by 7. Clear? And this has to be divided by that 6 over 13 into 7. Clear? 1 by 7 minus 6 over, this is 91. 6/91. When you do the iteration, this is 1/13. This is 1/13 actually. 2/13. This is calculated, and you will get the value 1/13 here. Clear? However, it is 91. This is 40. 13 minus 6. 7/91. This is 1/13. Clear? This is the last step. Another 2 minutes. We are going to close it. This is 4 here. Here, if you look at here, this is the unitary matrix. This is the unitary matrix. This is the important part. Clear? If you look at here, this is the unitary matrix. Means we will get the answer here. When we started with here, this was the unitary matrix, S1, S2, and these were the incoming here incoming variable. If you look at here, and here, if you look at here, this is the incoming variable. So this is 4 here, this is 7 here, this is 28/13 minus 7/13. Clear? This is 21/13. Clear? This is minus 4/13 plus 8/13. Here, if you get it here, this is minus 4/13. This is 14 over. This is 14 over. This is 10/13. This is 10/13. And Cj minus Ej. If you look at here, this is 0 here. This is 0 here. Minus 21/13. This is minus 10/13. All values are 0 and negative. The solution obtained is the optimal one. This is the optimal solution. What is the value of y1? y1 is equal to 6/13. y2 is equal to 1/13. When you substitute it here, look at here. When you substitute it here, this is maximum W, that is 4 into 6/13 plus 7 into 1/13. Clear? This is 24/13. This is 7/13. This is 31/13. And the last step. And if you substitute, this value represents your x1, x2. Clear? When you look at the primal problem, this is minimum function. Minimum z. What was that one? X1, x2. What is x1? 21/13 with the sign change of sign. You will substitute here. This is 10/13. This is 31/13. And if you look at here, maximum W is equal to minimum Z. What is here? This is the dual problem. This is the primal problem. This proves your results also. That's it from my side. If you have any question, you may ask me. So today we have discussed the simplex method by converting the primal problem into the dual problem. That's it from my side. Thank you very much.